Hi, this video is focused on part 4 of Domain 1, that is Design Principles of Secure Cloud Computing. Please subscribe the channel if not yet done. There are different the data lifecycle states starting from the create, store, and we have use, share, archive, and the destruction of the data. So when we talk about the create, that means it is a generation of any new digital content or any alteration, updation, modification of the existing content. When we talk about the store, it is an act of committing the digital data to some sort of a storage repository, and typically occurs nearly simultaneously with the creation. When we talk about the use, it means some kind of processing, means some kind of data reading or view has happened, or otherwise use in some sort of activity, not including the modification. So modification is not the use, it is a create. Remember from exam point of view. Share, information is made accessible to others, such as the as between the users to customers or to partners. And then we have archive. It means the data leaves the active use and enters the long-term storage, that is archive. Destruction, from the destruction purpose, when you are done with the information and you don't need that information anymore, and that is confidential, or that has some classification level. So depending on the classification, it depends how you want to destroy that information. Some data sanitization techniques, like for the destruction, you can overwrite the data with the random bits, or if it is really the classified or the confidential data, then the uh, crypto shredding comes into the play. So crypto shredding, what it does is, it encrypts the data with the key, and we erase this key. Then this data becomes the unusable. So that is the crypto eraser. So from exam point of view, if any use case, or the question around, what is the best possible way to destroy the data once it is decided that we don't want to store that data anymore, and we want to destroy that, then crypto shredding is the best option. To remember these data life cycles, the CSUSAD is the short form that we should remember. C for create, S for store, U for use, S for share, A for archive, and D for destroy. Business continuity and disaster recovery. So it is very important to plan something for the business continuity, and how to contain the business, how to continue with the business, considering the services and assets which are there in the cloud, and if something has happened, how to recover from the bad state to the good state. So continuity management is the process in which the risks and threats to the ongoing availability of the services, business functions, and the organizations are actively reviewed and managed at set intervals. So the objective of the continuity management is to plan how to continue with this business assets, and how to ensure that these maintains and these remains in the services without any issue. Disaster recovery focused on the restoration. So let's say if something has happened on your assets, and you have to now recover, so that is the disaster recovery. It is purely focused on the recovery, how to bring the resources back to the normal state. So there are different plans for the disaster recovery. um, Remember from BCDR point of view, ensure that the continuity and the recovery within the given cloud provider, and there are some tools and techniques to best architect your cloud deployment to keep things running. If either what you deploy breaks, or a portion of the cloud provider breaks. Also, prepare for and manage the cloud provider outages. This extends from more constrained problems that you can architect around within a provider to wider outages that take down all or some of the providers in a way that exceeds the capabilities of the inherent disaster recovery controls. Also, considering the options for the portability in case you need to migrate the provider or the platform. This could be due to anything from desiring a different features set to complete the loss of the provider. If, for example, they go out of the business, or you have a legal dispute. So, lock in, lock out, these things we need to take care of. We need to also decide that what is the share responsibility from the BCDR point of view with the cloud provider and cloud customer. Understand your supply chain risk, for example, the vendor or third party factors that may impact your ability to conduct the BCDR activities. Next is the BIA. First of all, we need to perform the BIA, that is the business impact analysis or the assessment. So, as part of this exercise, we need to understand, we need to identify all our assets, and we need to understand their criticality. We need to classify those assets, and based on the classification, we decide, okay, this kind of security controls that we can apply to mitigate these risks. And then we have the after the BIA, then we plan the as part of the BCP, the business continuity plan. We need to consider all those resources in the BCP, and involve the system owners or the information owners of those assets, and take their consent, discuss with them all those risks, and in agreement to the information owner or the system owners, we need to plan the mitigation accordingly for those. Don't drive yourself crazy by planning for full provider outages. Sometimes we feel that okay, everything we have critical, and we perceive the loss of control, and based on that we decide the full provider outages to consider. But first of all, look at the historical performance, and based on that we decide the cost, and we decide on these aspects. Address the technical alternatives, procedures, workflow, staff, and the other business necessities while we are planning for the business continuity. Testing approach. So it is very important to test your business continuity. Um, you know, the testing approach is the tabletop exercise, where essential participants work together at a scheduled time to describe how they would perform their task in a given BCDR scenario. It has least impact on the operations. Walk in, walkthrough drill. The walkthrough drill, it moves beyond the involvement of a tabletop exercise, where the attendees practice the certain functional steps to ensure that they have the knowledge and skills needed to complete them. Acting out the critical steps, recognizing the difficulties, and resolving problems is critical for this type of test. Then we have functional drill, or the parallel test. So we also call it as the parallel test, because this functional test is actually happening on the actual function of the business, and this goes in parallel with the operations. So we have two parallel servers. One is the backup server and another is the primary server. So this happens on that. Full interruption is something where the entire organization takes part in an unscheduled, unannounced practice scenario, performing their full BCDR activities. So this is something that is the most crucial, and that may have severe impact on the operations. We have due diligence that are required to review plan of the cloud service provider and SLAs in relation to these points. RPO is something where the recovery point objective. For example, if something goes wrong, we need to decide, okay, what is the recovery point objective that should be okay to the business. For example, if we have 1 month data, and let's say this is 30 days of period, and something goes wrong here, so the services are down, and now we feel that to recover this service, if we could just recover the last 15 days of data, we are good with that. So that is the recovery point objective. So that is here, the recovery point objective is the 15 days. Recovery time objectives, what is the time, what is the tolerable time for the business, where the business can sustain if we recover our services within, let's say, 30 minutes. Then the recovery time objective is 30 minutes. Okay. Interdependency, what are the dependent services, what are the dependent vendors, providers that we need to discuss during the SLAs, and with the provider. Priority of the restoration, so this is very important. You may have let's say 10 servers or 10 services. You may ask the in the priority, let's say 1 to 10, right? You need priority number 1 server to be restored first, or you may decide the least priority server first, because the least priority, if you restore that, um, that may have the easiest way to recover. So easy service has to be restored first, but the critical service has to be restored first. So it goes hand in hand, the criticality of the asset and the easiness of the restoration. Compensation for loss, this has to be discussed in SLA, and when you are agreeing on the contract with the provider. Point of contact and escalation, so this is very important when you discuss any such thing with the provider, and discuss SLAs, then it becomes very important to identify those point of contacts and escalation. Important from the SLAs, that you need to identify the single point of failures, especially the undocumented single point of failure that should not exist. So that has to be discussed for SLA. Migration to the alternative CSP should be possible if you want, and if you feel that the cloud service provider is not able to bring up the services, then you should have some alternative of the other CSPs, where the data backups are included. Incremental backup should be allowed. The user to select the desired settings, coverage, and frequency, for example. So these are all important aspects to be discussed for the SLA with the provider. Cost benefit analysis, the key driver for the adoption of the cloud computing, because we feel that this is in the operational model, and whatever we use, we just pay. We do not need to have the total cost of ownership like we have in the capex model in the traditional infrastructure. Resource pooling, this is the characteristic that makes the cloud environment a lot economical option. Capex to OPEX, of course, because in this model we are moving from traditional to the operational model. Time and efficiency. You need, you have a lot of time which is saved in terms of bringing up the services, and if we need the redundant servers, it is available immediately, and without any wastage of time. Depreciation of the resources, you don't need to consider, because you are in OPEX model and not in CAPEX model. Saving of utilities and cost, it is choosing cloud can reduce the cost significantly. Software licensing and maintenance cost, it is all on the usage basis. Thin client, again, this is thin client based. You just need to access using your thin clients. Pay per use. Security considerations for the different cloud strategies. We have different attacks and different things in the cloud infrastructure. For example, we have the virtual network. It contains the virtual switch software that controls the traffic between virtual NIC and physical NIC. We have then VM attacks. VM on the same physical machines can attach each other because they share the same hardware and software resources, basically through the hypervisor. The hypervisor attacks, basically it is compromising the hypervisor, which give the control over VMs. Common attacks that are hyperjacking, installing the rogue hypervisor that can take control, VM escape, crashing the guest OS to get out of it, and running an arbitrary code in the host OS. So this allow the malicious VM to take control over the host OS. Rootkits, the VM based rootkits, these are installing the malicious hypervisor um, on the fly or on manipulation to gain control. Virtual switches, the modification of switch control, switch configuration, VLAN, trust zone, and ARP table. DOS controls, DOS attacks. So DOS attacks is denial of service, basically to bring down the services, bring the services down. Misconfiguration at the hypervisor can make one VM to utilize all the resources, making other VMs unavailable. Because common VMs, sorry, different VMs, these are using the common hardware, and here if one VM is malicious VM is configured in a way to consume all the resources of that server, actually that will impact the operations of the other tenants on that server. Co-location, the multiple VMs residing on a single server and sharing the same resources increase the attack surface and risk of VM to VM and VM to hypervisor compromises. Multi-tenancy, this is the information leakage because VM to VM and VM to hypervisor compromises. Loss of control, user don't have control over the location of the data center and services, and CSP is not aware of the content that they run. Network topology, due to the lot of changes in the cloud, especially the VMs that are being added or removed or moved from one host to another, this creates a challenge for the network topologies. The logical network segmentation, isolation is the important for the sensitive information, VLAN, netting, bridging, etc. No physical endpoint due to the virtualization. Physical endpoints, switches, servers, NIC have been reduced. Single point of access. Hosts have limited NIC to all VMs. The security considerations for the platform as a service, where the system and resource isolation, the system should not have shell or root access to the servers running. Admin should be segmented. The admin activities should be always be restricted. User level permission, each instance should have their own permission, and also ensure that no authorization creep is there, accumulation of the privilege over the period of time. For example, somebody was responsible for some critical task and they moved to the different department, and now they keep on accumulating the privilege accesses. User access management, this helps to protect the confidentiality, integrity, and availability of any asset. The key components here are the intelligence, for example, collection, analysis, auditing, and reporting based on the organization policies. Administration, onboarding, offboarding, or changing the account access. Authentication, we always prefer the multi-factor authentication on these kind of services. Authorization, least privilege should be applied. Also, the protection against the malware, backdoor, or Trojan. Once the backdoor is created, it creates a permanent attack surface, because if you have malware on your system, it opens the backdoor, and the attackers will always have access to your critical resources. Security considerations for the software as a service. Here, the data segregation, where the customer's data can be stored in the same location with the multiple tenants. You have multiple tenants, and the customer's data should be segregated so that there is no segregation at the physical level, but at least at the application should be maintained so that no other customer is able to access the data of other tenant. Data access and policies here. Access to the customer data should be reviewed, logged for the traceability, who has accessed and what was accessed, monitored. Um, CSP policies, the cloud service provider policy should match the customer's policy. This is important aspect for the SLA or the contract. When you finalize the contract with the cloud service provider, you need to ensure that your policies are being accepted and being agreed with the service provider. Web application security, given a large number of co-located tenants, if a vulnerability is exploited, the service provider and the customer will have a catastrophic situation here. Um, because if they are co-located, and this will have a severe impact, because the customer and the service provider are both are in the same range here. With this slide, we conclude this tutorial. Thanks for watching. Please like, comment, share, and subscribe to the channel for the regular updates. Thank you.